Which one of these two thick black lines is longer? A to B, which runs along the 10 houses on the left, or C to D, which runs along the 8 houses on the right? It looks pretty obvious that it's A to B. Until the card's flipped over to C to D, and you see that they're both exactly the same size. Believe it or not, both of these two lines are exactly 2.5 inches long.
Take for example these two gray rectangular columns, both of which are different shades of gray. Or are they? It turns out that they're the exact same, and yet even after knowing the illusion is there, your eyes refuse to see them as the same. Introducing colors produces the same result. I promise, no trick photography or editing effects have been applied. In fact, if you look up the Munker white illusion, you'll come across many more examples. Examine them in Photoshop and you can see that the colors are the exact same. A similar effect can be seen with this checkerboard illusion. Tile A clearly seems darker than tile B, but you know better by now, right? Even though your eyes can't see it, you know when I remove the surrounding imagery, the tiles will be the same color. So what's going on here? The truth is that scientists don't fully understand this phenomenon, and there are many complex biological and neurological factors taking place. Ultimately, our brains judge color and brightness in context. In other words, our brains compare the surrounding environment in order to create our perception. The purpose of our senses, or eyes in this case, is not to provide us with an absolute color or physical property of our external reality, but to interpret what we see as efficiently as possible in order to interact with our environment most appropriately. The tile illusion takes advantage of this phenomenon. Our brains know that shadows make objects look darker. As a result, the brain compensates by interpreting the tile as being lighter than it appears, until we take the shadow away. Perhaps the most blatant example is this gradient. The middle bar is simply one color. Remove the background gradient and it becomes obvious. Once again, the darkness of the background has affected our perception of the bar's color. Our perception is relative.
To win this game, all you have to do is see the reality that is in front of you as it really is. Here we have two panels, one with a black background and one with a white background. One of the dots is the same in both panels. And while you're trying to decide which it is, I'll state the obvious and point out that we can pretty much eliminate the light orange, the dark blue, and we can probably eliminate the pink and violet as well. So have you decided? Let's find out what the reality is. Here's the light blue. Of course, that's darker. How about the green? No. The reddish orange? Not the same. What about the gray? If you saw that it was the gray, then you must be a complete realist. Nearly every living organism is able to detect light. So seeing color for us as humans is one of the simplest things that the brain does. And yet, even at this most fundamental level, we see that context is everything.
When you look at this photo, you instantly know she has blonde hair, is visibly angry, and likely has some choice words to yell. Without any effort, you experienced fast thinking. But if you look at the following problem, something different happens. Sure, you immediately know it's a multiplication problem, and you knew you could solve it if you had the energy, but didn't. If you do try, your muscles will tense, your pupils will dilate, and your heart rate will increase. Now, you've experienced slow thinking. These two systems of fast and slow thinking dictate much of our perception and reaction in life. Take these lines for example. It's clear that they're different lengths, but if you measure them, they're actually the exact same length. Even now that you know, System 1 or your fast thinking can't stop seeing the illusion because it acts automatically. A similar effect is seen here. Which figure is the largest? Again, they're all the same size, but the suggestion of perspective and depth causes your System 1 to interpret the picture as three-dimensional, even though it's on a flat two-dimensional surface. It's making quick work of the available information, and so your conscious System 2, or slow thinking, must compensate after the fact and choose not to believe your intuition or instinct. Want to see your System 2 in action? I'll show you a string of 4 digits, you read them aloud, then add 1 to each of the original digits. If the card reads 3795, the correct response would be 4806. We'll then go to the next card and you'll do the same, followed by the next card. Ready? Go. Few people can cope with more than 4 digits, but even harder is add 3. The interesting bit is that though your pupils would have dilated, you often become effectively blind when you fully engage System 2. Did you notice the color of the text change? Or how about the fact that the numbers completely changed when I put them off to the side? Listen to the following puzzle. A bat and a ball cost $1.10. The bat costs $1 more than the ball. How much does the ball cost? Chances are your System 1 intuition was yelling 10 cents, but this appealing System 1 answer we know is wrong. In fact, the correct answer is 5 cents. Even if you worked out the correct answer, you likely thought of 10 cents along the way. System 1 is trying to work out an answer as quickly and seamlessly as possible, which is extremely beneficial in everyday life. If every activity required full mental effort, it would be exhausting. But knowing this allows us to understand that not all of our first impressions are correct. How many animals of each kind did Moses take into the ark? So few people detect what is wrong with this question that it's been dubbed the Moses illusion. In fact, Moses took no animals, Noah did. Again, our brain invests as little resources as necessary so that things run quickly and smoothly. Because Moses is not abnormal in the biblical context, System 1 unconsciously detects an association between Moses and ark and quickly accepts the question. In a similar way, System 1 generates context without you knowing. Reading each of the following may seem fairly simple. A, B, C, and approached the bank, and 12, 13, 14. But your brain actually interpreted these ambiguous statements without you ever knowing. You could have read it as A, 13C or 12, B, 14, but your brain created the context unconsciously. Also, you likely imagined a woman with money on her mind walking towards a building with tellers. But if the sentence before this was, they were floating gently down the river, the entire scene would have changed because bank is no longer associated with money. Without an explicit context, System 1 quickly generates one based on previous experience. In this case, you've likely visited more banks than rivers, and so the context is resolved accordingly. This ties into a concept called priming. For example, if I said wash, how would you complete this word fragment? Most would see soap, but had I just shown you the word eat, you'd be more likely to see soup. In this way, both eat and wash prime your thoughts. Though System 2 likes to think that it's in charge and knows what's going on, the truth is that priming effects have even been shown to affect and modify behavior. These arise in System 1, and you have no conscious access to them.
educate each other. Things are good in one context, but bad in another. Playing in the sprinklers is the best without a doubt, but not during a record-breaking drought. It's always impressive to play a piano masterpiece, but it's not as great in a room of escaping refugees.
You kidding me? They find us and kill us!
Context is
Oh, look at this little girl.
Context is
Honey, isn't she precious? No.
Context is everything.
We love Americans.
Context is everything.
What is that?
Laugh until you cry is a part of life that's vital, but don't do it in the front row of a child's flute recital. It warms the heart when friends throw you a party.
Congratulations, Mal!
But not when you're machine a new life out of your body.
Get out of here, you morons! Get out!
And they say that words can have different meanings in different contexts.
How's everyone feeling tonight?